Hi folks, Dilip Bhatnagar here. I hope you all have seen my previous 3 videos on integration. The first video was on introduction to integration, in which I listed the elementary standard integrals and have explained how to solve some basic integration problems. The second video was on integration by substitution technique, and the third was on integration using trigonometric entities. As we proceed forward, it is necessary to be clear on the integral formulas and the techniques we have learnt in the previous classes. It would be a good idea to repeat the integral formulas listed in the first video over the next few days so that we are clear about them. In this video, I shall explain the methods to evaluate the integrals of some specific functions using certain important integration formulas. The integration formulas that we will use here are as follows. The first one is integration of dx by x square minus a square is equal to 1 by 2a log of modulus x minus a divided by x plus a plus c. The second one is integration of dx divided by a square minus x square is equal to 1 by 2a log of modulus a plus x divided by a minus x plus c. Right. The third is integral of dx divided by x square plus a square is equal to 1 by a tan inverse x by a plus c. The fourth is integral of dx divided by root of x square minus a square is equal to log of modulus x plus root of x square minus a square plus c. The fifth is integral of dx divided by root of a square minus x square is equal to sine inverse x by a plus c. The sixth is integral of dx divided by root of x square plus a square is equal to log of modulus x plus root of x square plus a square plus c. If we observe these functions carefully, we notice that all of them have only dx in the numerator. All of them have only dx in the numerator. The first three have x square minus a square in the denominator, or a square minus x square in the denominator, or x square plus a square in the denominator. The next three have in the denominator either root of x square minus a square, or root of a square minus x square, or root of x square plus a square. Another thing that we notice is the coefficient of x square in all these functions is equal to 1. The coefficient of x square in all these functions is 1. Now we shall see the type of problems that we shall have here. The first type are those in which the functions are in the form of I is equal to integral dx by root by ax square plus bx plus c. Here we notice that the coefficient of x square is a. The coefficient of x square is a. Therefore, our first step has to be to make the coefficient of x square as 1. Now, to do that, we have to divide and multiply the denominator by a. so that we can make the coefficient of x square as 1. So that is the first step. So this, we write this as integral dx divided by, now first I'll multiply by a. I multiplied the denominator by a. Now I'll divide the denominator by a. So I'll get ax square plus bx plus c whole divided by a. So now I can take 1 by a outside because that is a constant. So 1 by a integral dx by here. Now I have got ax square by a, so that gives me x square. Next I have bx by a, so that gives me b by a into x plus c by a. Right? So we have achieved our first step, where now we have made the coefficient of x square as 1. Our next step is we have to add and subtract 1 by 2 of the coefficient of x whole square. Therefore, I will get, that is in the denominator, so I will get 1 by a integral dx divided by x square plus b by a into x. I repeat, I will have to add and subtract 1 by 2 times b by a whole square. So that will become plus b by 2a whole square. I've added it. Now I'll subtract it, minus b by 2a whole square, and now I'll write the last plus c by a. Got it? Now I'll rewrite this as 1 by a integral. Now this particular portion I can write it as x plus b by 2a whole square, right? So I will get here dx divided by x plus b by 2a whole square, right? And the remaining is this portion, so I can write it as plus c by a minus b by 2a whole square, right? Now the next step would be to take this x plus b by 2a as t. So I'll get let x plus b by 2a is equal to t. Now I differentiate both sides. Differentiating both sides. So I'll get dx is equal to dt. Further, I also have to express c by a minus b by 2a whole square, this part as some k square. Therefore, I will get I is equal to 1 by a integral. Now dx is equal to dt, so I can write dt by, now x plus b by 2a is equal to t, so I can write t square plus this portion c by a minus b by 2a whole square is equal to some k square, so I can write k square here. Now we can use the standard formulas that we listed in the earlier slide, and we can find the integral, and after that we have to replace the value of t, that is t is equal to x plus b by 2a. Now this is the method that we will follow to find the integrals of this form. Now let us do a few sums that will help us to understand this procedure much better. Okay, the first example I have, I is equal to integral dx divided by 3x square plus 13x minus 10. Now, as I explained earlier, our first step should be to make the coefficient of x square as 1. Our first step should be to make the coefficient of x square as 1. Therefore, we have to multiply and divide the denominator by 3. Okay, so let us proceed with this step first. Therefore, I is equal to integral dx divided by, now since I have to make the coefficient of x square as 1, I first multiply the denominator by 3 and I also divide the denominator by 3. So I get 3x square plus 13x minus 10 whole divided by 3. Right? Now I can take 1 by 3 outside because it's a constant. So I write this as 1 by 3 integral dx divided by, now 3x square divided by 3 gives me x square plus, I'll get 13x by 3, 13 by 3 into x minus 10 by 3. So that was the first step. Now, as I mentioned earlier, the second step is, in the denominator I have to see what's the coefficient of x. The coefficient of x is 13 by 3. So I have to add and subtract 1 by 2 the coefficient of x whole square. So for I will get 1 by 3 integral dx divided by x square. Now the coefficient of x is 13 by 3. So 1 by 2 of 13 by 3 is 13 by 6. So first I will write 13 by 3x as it is. So 13 by 3 into x. Now I will first add 1 by 2 times the coefficient of x whole square. So I'll get 13 by 6 whole square, and I'll subtract the same amount, 13 by 6 whole square minus 10 by 3. That is this part. I am drawing by exactly the same method as I had explained in the earlier sum. So now this will give me 1 by 3 integral dx divided by, now this particular portion I can write it as x plus 13 by 6 whole square and the remaining I'll write as this 13 square is 169 by 36 minus 10 by 3. Right? Now I will continue. This is equal to 1 by 3 integral dx divided by x plus 13 by 6 whole square. Now the remaining portion, when I calculate, I'll get minus 17 by 6 whole square. Right? I have expressed this remaining portion as some k square as I had explained in the earlier process. So now the next step is I have to let x plus 13 by 6 is equal to some t. Now differentiating both sides, I'll get dx is equal to dt. Right? Now I can rewrite this as I is equal to 1 by 3 integral. Now dx is equal to dt, so I can write dt here, and x plus 13 by 6 is equal to t, so I can write t square minus 17 by 6 whole square. Right? Now we can use the formula. We can use this formula. Integral of dx by x square minus a square is equal to 1 by 2a log of modulus x minus a by x plus a plus c. Therefore, now I will get I using this formula. I'll get I is equal to, first I'll write 1 by 3 as it is. Now 1 by 2a, so 1 by 2, and a is 17 by 6, so I'll get 17 by 6 here, and then log of t minus a A is 17 by 6 by t plus a plus c. Now putting the value of t now I will get I is equal to, now let me see, 2 3 6, these two will get cancelled, and I'll get 1 by 17 log of, now t is x plus 13 by 6, so I'll put x plus 13 by 6 minus 17 by 6 divided by t is x plus 13 by 6 plus 17 by 6 plus c. This can be further simplified. Okay, now let us see another sum. Yes, now in the second example we have I is equal to integral of dx divided by x square minus 6x plus 13. Now, as I explained earlier, the coefficient of x square has to be made 1. Here we have seen that the coefficient of x square is already 1, so we can skip that step and we'll go forward directly to the second step. Therefore, I is equal to integral dx divided by x square minus 6x. Now the coefficient of x is 6, so I have to take 1 by 2 the coefficient of x whole square. We have to plus and minus that. So now this will give me plus 6 by 2 whole square minus 6 by 2 whole square plus 13. Right? So this will give me integral dx divided by x square minus 6x plus 3 square minus 3 square plus 13 this will give me integral dx divided by, now this portion can be written as x minus 3 whole square and the remaining will give me 4, which is nothing but 2 square. Now the next step is let x minus 3 is equal to t, differentiating both sides, I get dx is equal to dt. So this is equal to, that is I is equal to integral. Now dx is equal to dt, so I'll write dt here. X minus 3 is equal to t, so I'll write t square plus 2 square. So here I can use the formula dx by, and that is integral of dx by x square plus a square, right, is equal to 1 by a tan inverse x by a plus c. I'm going to use this formula here. So I will get I is equal to 1 by a is equal to 2, so 1 by 2 tan inverse, okay, t by a, so it will become t by 2 plus c, right? Now putting the value of t, now I will get I is equal to 1 by 2 tan inverse, now t is equal to x minus 3, so I'll get x minus 3 by 2 plus c, right? Now let's see the next. Now we will find that some integral functions are in the form of integral of dx by root of ax square plus bx plus c. Now the method that we use for solving these is very similar to that we had followed earlier. So let us solve the next sum using the same method as we did earlier. So now here again, here we have to make the coefficient of x square as 1. Here the coefficient of x square is 5. Now we have to make the coefficient of x square as 1. So we use the same method as we did earlier. So I is equal to integral dx divided by whole root of the whole root of, okay, now first I multiply by 5, right, and I divide the whole thing by 5 also. Get 5 x square minus 2x divided by 5, right? So I will get this is equal to integral I can rewrite this as dx by now this is root 5. I'll write it here, root 5. I'll write it separately into whole root of, now this is 5x squared by 5, so it will become x squared minus 2 by 5 into x, right? Now 1 by root 5 is a constant, so I can take it out of the integral, so I'll get 1 by root 5 integral dx by whole root of x square minus 2 by 5 into x. Now, as we did in the earlier problem, the coefficient of x is 2 by 5. So here in the denominator below this root, I have to plus and minus 1 by 2 of the coefficient of x whole square. So I'll get this is equal to 1 by root 5 into dx divided by whole root of x square minus 2 by 5x, right? Now plus, you'll get 1 by 2 times 2 by 5 whole square right, and minusing the same amount 1 by 2 into 2 by 5 whole square, right? So here I'll get continue. Therefore I is equal to 1 by root 5 integral dx divided by whole root of x square minus 2 by 5 into x plus 1 by 5 whole square right, minus 1 by 5 whole square. So this will be equal to 1 by root 5 integral dx divided by, now this particular portion can be written as x minus 1 by 5 whole square. So I'll write here whole root of x minus 1 by 5 whole square, and the remaining is minus 1 by 5 whole square. Now we follow the same method. Let this portion be equal to t. So let x minus 1 by 5 is equal to t, differentiating both sides. I get dx is equal to dt. Yeah. Therefore, I is equal to 1 by root 5 integral. Now dx is equal to dt, so I'll write dt by root of, now x minus 1 by 5 is equal to t, so I'll write t square minus 1 by 5 whole square. Now I will use the formula integral of dx divided by root of x square minus a square is equal to log of modulus of x plus root of x square minus a square plus c. Therefore, here I can write I is equal to 1 by root 5 integral of a log of t plus root of t square minus 1 by 5 square plus c. Now we have to put the value of t. Putting value of t. So I'll get I is equal to 1 by root 5 log of t is equal to x minus 1 by 5. So I'll write x minus 1 by 5 plus plus I'll continue here root of t square, that is x minus 1 by 5 whole square right, minus 1 by 5 whole square right, modulus plus c. And when we simplify further, I'll get this as 1 by root 5 log of x minus 1 by 5 plus root of x square minus 2 by 5x less plus c. Right, friends? Now let us see another problem. Okay, this is the last problem that we shall see today. Now here I have got I is equal to integral dx divided by whole root of 7 minus 6x minus x square. Right, now I'll continue this. I is equal to integral dx okay. Now the coefficient of x square is already 1, so I don't need to make any changes that side. So I'll get dx divided by whole root of 7 minus I'll write this as x square plus 6x, right? This I'll write as integral dx. I'm going to follow exactly the same steps. Whole root of 7 minus, okay, I'll rewrite this x square as it is, plus 6x. Now the coefficient of x is 6, so I'll write plus 6 by 2 whole square minus 6 by 2 whole square. Right? So this will be equal to integral dx divided by whole root of 7 minus, now this I will get here x square plus 6x plus 3 square, okay, and here I'll get plus 3 square. So this will give integral of dx divided by whole root of, now 7 plus 9 is 16, so I can write as 4 square minus, now this part I can write as x plus 3 whole square. right? Now I will take let x plus 3 is equal to t, therefore dx is equal to dt, therefore I is equal to integral dx divided by, dx is equal to dt, so I'll write it as dt dt divided by whole root of 4 square minus x plus c equal to t minus t square. So now we can use a formula integral dx by root of a square minus x square is equal to sine inverse x by a plus c. Therefore I can write this as I is equal to, now sine inverse now this is t by 4 plus c. Now putting the value of t, I is equal to sine inverse x plus 3 by 4 plus c. Right, friends? Okay, thanks folks. I hope you all have found this class useful. In the next class, I will continue with the integrals of some particular functions. I'll continue with the same chapter. Please like, share and subscribe to the channel to view more informative videos. You can press the bell icon to receive notifications whenever I post a new video. You can put your questions in the comment section below or email me at dlpbhatnagar@yahoo.co.in. Thanks.